So just a recap of the basics. When it comes to arithmetic sequences, remember we calculate the difference by saying term 2 minus term 1 is the same as term 3 minus term 2. Our arithmetic TN formula, A plus N minus 1D, and then calculating the sum of an arithmetic series, we can use N over 2 into 2A plus N minus 1D, or if we know the last term of the pattern, you can use N over 2 into A plus L. When it comes to geometric patterns, we calculate the constant ratio by dividing term 2 over term 1 is equal to term 3 over term 2. The nth term, Tn, equals AR to the n minus 1. We can use either one of these two formulae to calculate the geometric sum, and then calculating sum to infinity. So this is just a nice little table with everything summarized over here for us. Let's have a look at the first question. All right, so they want us to solve simultaneously matrix, and they have given us two equations. The first equation is 3y equals 1 plus x squared plus x squared. And the second equation involves some sigma notation. So this is what we were talking about this evening with sigma notation. Incidentally, sorry, before we actually jump into this question, let me just recap very, very briefly sigma notation. So if I have a sigma symbol over here, and let's say I say n is equal to 3, and I have a pattern that goes 5n minus 1, and I put 100 at the top over there, how do I calculate the number of terms in the pattern? So we're just looking at this one over here on the side, first of all, this one here. How would I calculate n, the number of terms in this particular series? Can anybody tell me? There we go, Ayanda. So the number at the top minus the number at the bottom plus 1. Okay, so the number of terms in this particular pattern would be 100 minus 3 plus 1, which would be 98 terms. Okay, so if we know that, Ayanda, then we probably know sigma notation pretty well. All right, so what does the 3 represent? Let's just finish this off. What does the 3 represent? Put it in the chat, guys. What does n equals 3? What do I do with that 3? Okay, I use it to calculate the first term. Okay, by subbing it in. So the first term, Ayanda, would be, so A, the first term of this pattern would be 5 times 3 minus 1, which would be 14. It's your starting point. Good, Sihawu. Okay, how would I calculate the last term in this pattern? How would I calculate the last term? Plug in 100. Okay, so that's where I end. Good. So the last term would be 5 times 100 minus 1. Okay, so that would be 499 would be the last term. Does this particular pattern have a D, or does it have an R? Is it a D or an R? Is the pattern arithmetic or geometric? Good, Lesedi. Okay, it is arithmetic, which means it has a difference. Okay, if I wanted to calculate the difference between the terms, how would I do that? Can anybody tell me what the difference is? Again, you can pop it into the chat if you don't feel like speaking. Where are we getting the 5? And it's part of the rule. So 5n minus 1 is the rule. Okay, so we're calculating the sum from n equals 3 to 100 of 5n minus 1, right? Yeah? So how would I work out what D is in this case? Okay, Sinanhlanhla, thank you. That's right. Okay, Sinanhlanhla has DM'd me. Good. Thinking Sinanhlanhla, I'm getting the same D as you. Let's just see what the others say. What are you working out the D to be? I agree. Okay, so Lesejo, yes. Msomi, yes. Okay, the difference is 5 in this case. It certainly is. All right. Do I need to explain why it's 5 or are we all good? Can I move back to all these 5s? Can I move back to question 5 on the left-hand side? Because this was just clarifying the basics. Please explain. Okay. So Lesedi, just very quickly then, if you wanted to remember, let's just get a bit of color. Okay, remember T1, term 1 is A, right? And we've worked out what that it would be 14. So in order to get the difference between these two, we need what term 2 is. So term 2 would be created by subbing 4 into our rule. So in this case, term 2 would be 5 times 4 minus 1, which should be 20 minus 1, which would be 19. So your difference would be 19 minus 14, which is where the 5 comes from. Does that make sense, Lesedi? Cool, you've got it. All right, lovely. Okay, so that's where it comes from. Okay, so let's go back to this. So we've got equation number 1, because remember when we solve simultaneously, we've got to have 2 equations, right? So we've got equation number 1, which is 3y equals 1 plus x squared. And clearly we need to make a second equation, because if we want to solve simultaneously, we need 2 equations. Can anybody help me make the second equation using the sigma notation that we have here? How are we going to make a second equation, guys? What are we going to write? So have a little look at it. I don't want to tell you. I want you guys to think and to problem solve and to try it out. If you get it wrong, it doesn't matter. No one's going to laugh at you. Just think about it for a minute and then tell me what you think we should write to make our second equation. So let's start. Let me try and help you by asking some interesting questions or asking some probing questions. First of all, okay, what does the 5y on the right-hand side represent? When it says equals 5y, what does the 5y represent? Exactly. Okay, see how I work? Brilliant. Okay, so the sum to n number of terms in this case is 5y. Okay, so things are adding up to, and it's going to be equal to 5y. That's our SN. Good, lovely. Okay, just have a look here. Sum, yes, Nicole. The Tile, the sum of arithmetic. Yes, you're on the right track. Sinenhlanhla. You are getting very close, Sinenhlanhla, very, very close. First of all, how many terms are there in this series? The number of terms in this series is? How many terms are there in this particular series? Remember, the series is going to be our second equation. 2, good, yes, well done. So there are 2 terms and they add up to 5y. Okay, there are 2 terms and they add up to 5y. 4 minus 3 plus 1 gives us 2. There are 2 terms. Ah, okay, Sinenhlanhla. Okay, so what you're sending me, Sinenhlanhla, let me just have a look at this. Is it? Yes, Sinenhlanhla, okay. Good, well done. Good. So you can get started on solving simultaneously, Sinenhlanhla. Let's just see how everybody else does. Good. Well done, Sinenhlanhla. That's beautiful. Nice thinking. Okay, so Sinenhlanhla's on their way. What about everybody else? Remember, what does the k equals 3 at the bottom represent, Matrix? It represents where we start subbing in, doesn't it? Okay, so that represents where we start subbing in. So you've got x brackets, k minus 2, we're going to start subbing in at 3. Then after we've subbed in 3, we would sub in 4. Okay, but remember, there are only 2 terms in the pattern. We start subbing in at 3, and the last number to be subbed in is 4. And when we add these 2 terms together, we need to get 5y as our SN. Okay, so 3 minus 2 is 1. So 1 squared would be 1x. 4 minus 2 would be 2. 2 squared is 4. And that is equation number 2. Well done, Sinenhlanhla. You saw that straight away. Are the rest of us following? Is this making sense to everybody? Thumbs up, thumbs down. Are you okay? Yes. Okay, so now I want you to solve simultaneously. We've done the hard part together. Lovely. You guys solve simultaneously for X and Y, please, Matrix. Okay, Zwanaka, you need some help. I'm going to help you. Okay, so Zwanaka, can you tell me what it is that you didn't understand? Everybody else is solving simultaneously. Zwanaka, where did I lose you? And thank you for being honest and saying thumbs down. Zwanaka, you're welcome to unmute. Where did I lose you? Okay, so was it forming the second equation, Zwanaka? Was that the difficult part? Okay. So in other words, Zwanaka, do you not know where the x plus 4x comes from? Is that what you're saying? Basically. Okay. All right. So the rule that you're subbing into, Zwanaka, is this one. X into k minus 2 squared. That's the rule that you're subbing into. So when we work with sigma notation, we always have to sub in order to create the terms of our series. The first number that we're subbing in is the 3. So I'm making k equal to 3. So here you can see I've made k equal to 3. All right, and then I've written down what my rule is. Over here, I decided, remember earlier, that there are only 2 terms in my pattern. So there's the first term, subbing in 3, and there's the second term where I sub in 4. Now 4 is the last number to be subbed in. So again, I've made k equal to 4. And when I add those 2 terms together, I'm going to make it equal to 5y, which is my Sn. Okay, so that's why we end up with x plus 4x, because 3 minus 2 is 1 and 1 squared is 1. X times 1 is 1x. And for the second term, 4 minus 2 is 2. 2 squared is 4. And 4 times x is 4x. Okay. Anyone got answers for x and y? Katleho, yes, go for it.
Hi, ma'am.
Hello.
Um, ma'am, I just wanted to know when you what's this, expand the brackets or remove the brackets, do you first multiply the x or do you first do the exponent?
You got to do the exponent first, okay, Katleho? Otherwise, you're breaking mathematical laws. Okay, we've always got to do exponents before we multiply. So, for example, if I had something like this, 3 times 2 to the power of 3, you've got to say 2 cubed first and then times your answer by 3. You can't say 3 times 2 is 6 and then raise it to the power of 3. Okay. All right. Sinenhlanhla, you're not wrong. Those are the correct answers. Okay, so that was really nice, Sinenhlanhla. Well done. That one made a lot of sense to you. Let's just see what everybody else comes up with. Sinenhlanhla, since that worked out nicely, I'm going to give you this question. This is going to be the next question that we work on. So, Sinenhlanhla, I'm just going to put it over here in the bottom right-hand corner, and you can start thinking about that before we get started. Everybody else, don't stress. You carry on with question 5, and then like Sinenhlanhla, I want you to share your answers with me, and then we can carry on going. Okay, so the rest of us, we're still solving for x and y. If you are stuck or you think you don't know what to do next, I'm talking about in the solution of question number 5, please let me know.
We can do this, Matric. Let's go. We can do it.
Okay, Ayanda, I got the same value but a different sign to you. Okay, I'm just going to wait a couple more minutes and just see how everybody is. Are we struggling, Matrix, to get X and Y, or are we still just busy? Katlego? Go for it,
Hi, ma'am.
Katlego. Hi, Katlego.
Ma'am, oh,
Are you?
ma'am, I kind of forgot how to multiply a whole number with a fraction. I'm so sorry, ma'am. I was on a holiday mode. Like, I don't want to lie about that.
No, it's okay. All right, so
Okay, ma'am.
when you say multiply a whole number with a fraction, do you mean something like, hang on a second, do you mean something like 3 times 1 over 2? Is that what you mean?
Yes, ma'am. Yes,
Okay,
ma'am.
so no problem. When you multiply a whole number with a fraction, the rule when you multiply fractions is to multiply numerator with numerator and denominator with denominator. So 3 means 3 over 1. So you'd say 3 times 1, multiply the numerators over multiply the denominators, and that's how you'd get your answer. Okay,
Thank you so much, ma'am. Thank you, ma'am.
it's a pleasure. It's a pleasure. Okay, so Lesedi, you said you were struggling a little bit. No stress. Lesedi, let's talk about what we would do in the next steps to get our answer. So Lesedi, on the left-hand side, you would have said x plus 4x is 5x. And if 5x is equal to 5y, then it stands to reason that x must be equal to y, right? Did you get that, Lesedi? Did you get x and y are the same? Yes. Okay, lovely. So now go and substitute back into the other equation. Remember, x is y. So instead of 3y, you're going to say 3x. So over here, we're subbing in there. Okay, x is y, right? So 3x equals 1 plus x squared. This will be a quadratic Lesedi. So let's bring the x squared to the front. X minus 3x is minus 2x. And then we're going to bring down the plus 1. Okay, and once we get to this stage over here, we can factorize. So this is a perfect square trinomial. There we go. Well done. Mozi, I hope I pronounced Mozi Buddy. I hope I pronounced your name correctly. Oh, Zwanaka, and you've got load shedding. Sorry. Zwanaka, you'll be able to come back and watch this lesson, okay? You're only going to lose half an hour, which I know is still not great. Okay, so what we should have worked out is that x is 1. And if x equals y, that means that y will be equal to 1 as well. Okay, any questions? No questions, we all good. Okay, So let's go on. Okay, so somebody else did raise a hand. Let's have a look. Ontetile. What's wrong, Ontetile? Hello, how are you?
I'm good, and you, ma'am?
I'm fine, thank you. What's your question?
Ma'am, like I got the X value, ma'am. Can you please just explain one more time why X and Y are equal?
Sure. So that comes from simplifying the second equation over here. So over here where I'm putting this arrow, the orange arrow, you've got x plus 4x equals 5y. So x plus 4x is 5x. And so if 5x equals 5y, then if you divide both sides by 5, it means that x and y have to be the same.
Okay. Okay. Thank you, ma'am.
Okay, that's where it comes. Okay, cool. All right, so now I want to have a look at this question over here that Sinenhlanhla has been working on for a little while. Don't know how it's going for you with that particular question. All right, if there's anybody else that's already done this and wants something else to challenge them, yeah. Okay, Sinenhlanhla says this is quite difficult, but that doesn't matter. We're going to talk about this one together. So let's have a look. Okay, this is again a little bit of problem solving, but again, it is application of the basics. Okay, always, always, always application of the basics. Okay, they have given us something that's quite unusual. We've got the sigma symbol. We've got at the bottom k equals 2n. Our rule is tk. And we've got n squared at the top. And they've told us that there are 9 terms in this series. Okay, and they want us to calculate the value of n. So we need to solve for n. Okay. So n the number of terms in a series. How is it in a sigma notation? How is it calculated? How do we calculate n, the number of terms in a series? Remember our basics that we were talking about earlier today? It's the number at the, so like with this one here, we calculated n. I know I've rubbed it off already. Remember, we calculated n, the number of terms in the pattern, by taking the number at the top, minusing the number at the bottom, and adding 1, right? Remember that? Number at the top minus the number at the bottom plus 1. That does not change. You've got to apply the basics that you see to any problem-solving question. So they tell us there are 9 terms in the series. So that means that n is equal to 9. Okay, the number at the top. The number at the top in this case is n squared minus the number at the bottom. The number at the bottom in this case is 2n plus 1. Okay, so that means that n squared minus 2n plus 1 is equal to 9. Do you see how it's application of the basics, including reading the information in this particular question? Does that make sense to everybody? Okay, so you were on the right track. Okay, Sinenhlanhla. Everybody happy with that? There are 9 terms in the series. They told us that. We can calculate the number of terms in the series by taking the number at the top, minusing the number at the bottom, and adding 1. Okay, so that means that n squared minus 2n plus 1 has to be equal to 9. So n squared minus 2n minus 8, factorizing, we'd get that. So either n is equal to 4 or n is equal to -2. Remember, n cannot be negative. Okay, so n has to be equal to 4. Let's just do that. And then we haven't written anything that contradicts itself. Okay, does that make sense to everybody? How are we feeling about this question? Matrixie, okay? Keithlin, okay, good. All right, say to Ayanda.
We're still fine.
No, they're still fine. Okay, everybody just went very quiet. So I was just panicking that I had either horrified or destroyed or I hope not.
Tile, is that like a hand to ask? Maybe Tile has a question. Hey, Tile, do you want to ask something? Your hands are still up.
Oh, sorry, ma'am. I forgot to put it down.
Okay, that's fine. Okay, so we seem to be all right with this particular question. Okay, let's go on and have a look at something else. Okay, so let's have a look at question number 3. So without using a calculator, determine the value of, and again, here is more sigma notation. Now, a lot of the time when we see something like this in an exam, we freak out, we forget about the basics, we don't think things through, and we leave it off and we go on to the next thing, all right? But again, just like I was showing you with the previous question, it's always the application of the basics. That's how we problem solve. Okay, we've got to know our basics so well so that we can apply them to what we see, right? If you have a look at this question, it is a question asking you to find a difference. Why do I say that? Why do I say you are calculating a difference? And what does the word difference mean? Exactly. So the word difference means you are calculating something where there was a subtraction or there was a minus, quite right. And we see the minus here. Let's just highlight it. Let's get a green highlighter. There's the minus over there. I hope that's made it more obvious and not, in fact, hidden it away. Okay, so you are calculating a difference. The difference between two things, two sums. So in other words, what you've got is a bunch of things that are adding up to one another. And then you're going to minus another bunch of things that have added up to each other. Does that make sense to everybody? So it's a series minus a series. Is that okay? You happy with that? A series minus a series? Thumbs up, thumbs down? Series minus a series? We good with that? Okay. Should I leave you to try this question by yourselves? Because after all, you know how many terms there are in each series. You know what the number at the bottom represents. You know what the number at the top represents. So if you want to, you can work with each part of the difference separately. And then once you've got an answer for the sum of the series, you can minus the one at the front, minus the one at the back. Yes? Okay, all right. So I'm going to let you guys do that by yourselves. And again, you can DM me your answers when you've got them so that we don't put anybody else off. Okay. No, Msomi, you're not trying to subtract two equations. You're actually subtracting two SNs. So you're calculating an SN using the first. You're calculating an SN. This is an SN. And this is a different SN. Okay, so it's not an equation. It's actually the answer that you're calculating is SN minus SN. So it's just two numbers. You're just working out the difference between two numbers. Okay. Now somebody else. Okay, does that help? Oh, there we go. Ayanda, wow, well done, Ayanda. Very nice. Good job. Okay, so Ayanda, we're gonna have to go and get another question for you because you've smashed that one. Good, Ayanda, well done. Very nice. I hope you didn't use a calculator, Ayanda. Okay, the rest of you keep going. I'm just going to snatch another question for Ayanda. Just go and get this one over here. There we go. All right, and just go back. That's fine. There we go. Ayanda, I'm just going to put that in the corner here for you. That's fine. Okay, so Ayanda, if you can, this one that I'm bouncing up and down, you can start having a look at that. Don't know if we'll have a chance to go through it before the end of this. We'll just see how everybody else is doing with 3.1 first. I'm going to give you guys another 3 minutes or so and see if anybody else has got an answer for question 3.1. Okay, so Keith Lynn, you're the second person who says you've got a difference of 1/2. That's not what I got, Keith Lynn. Okay, is somebody else coming through with the correct answer? Mosey, I hope I pronounced your name correctly. That is correct. Sorry, I just got a few messages coming in all at the same time here. Ayanda. Okay, that's fine. See how I'm gonna do it with you guys right now. Ayanda, no. What you sent to me, that's not how we would do that particular question. Okay. But we're going to talk about it. Well, I don't know if we'll have a chance to talk about it, but I'll give you something to think about before we go away. All right. So anybody who did get the answer for question 3.1, let's start doing this together and compare what I'm doing with what you've got on the page, because at least perhaps you could have got some marks for this particular question. All right, so remember, the number at the top is the last number that gets subbed in. The number at the bottom is the first number that gets subbed in. So we are creating fractions, okay? So the first SN is going to be created when y, the first number we're going to sub in for y is going to be 3. So 3 minus 2 would be 1, right? So that means, sorry, I should have just written it as is. We've got 1/1, which is 1. Now we want to calculate the second term. So we're going to sub in 4. So 4 minus 2 at the bottom would be 1/2, right? And then after we've subbed in 4, we would sub in 5. 5 minus 2, that would give us 1/3 plus. And then we could go straight to the very last term. Okay, so that would be when we sub 10 in. So 10 minus 2 would give us 8. So that would be 1/8. So can you see, whoopsie daisy matrix, this pattern is going 1 plus a half plus a third plus a quarter plus a fifth plus an eighth plus a seventh, plus a seventh plus an eighth. Okay, minus. Now for the second bit. Let's go and sub in again. For the second bit now, all right, we start by subbing in 3. So 1/3 minus 1, that would be 1/2. And then we would sub in 4. 4 minus 1 would give us 1/3. And then I'm going to jump all the way to the end. 10 would go in. I would end up with 1/9. Okay, now before I go any further, does that make sense to everybody? Thumbs up, thumbs down. Are you with me? Keith Lynn's happy, Sinent Lantla's happy, Naledi. Saw me. Okay. Pile, Leiden. Good. So good. Okay, so you're all feeling strong and you are with me at this point. Okay, so I haven't written every term. I don't need to. We don't need to. We don't have to write absolutely every single term in both SNs, all right? What happens, matrix, when you subtract brackets with lots of terms inside? What's going to happen to these values in the second bracket? What's going to change for them in the second bracket over here? Let me just, okay, so this half over here and this third and this ninth, what's going to happen to those? They're going to end up because of this minus here. What is the minus going to do to each of these? They're going to be negatives, exactly. So think about the pattern that's going on here. You've got 1 plus a half plus a third plus a quarter plus a fifth plus a sixth plus a seventh plus an eighth. And now you are going to minus a half and minus a third and minus da 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 da, including the 1/9. Okay, so if you have a look here, this half over here minus that half over there is going to add up to 0. This third here and that third there is going to cancel out. Now remember here, you would have had a quarter, isn't it? So here you would have had minus 1/4. So those are going to cancel as well. In front of this 1/9, you would have minus 1/8, wouldn't you? So that plus 1/8 and this minus 1/8 are also going to cancel. So what is left over? 1 minus 1/9. All the other terms add up to 0. And therefore, we would end up with a final answer of 8/9. Does that make sense to everybody? How are we feeling now? Sorry, Keithlyn. Shame. Everybody else is there too. Sibongile. Okay. All right. So it was only out of 3. So it's not, there's got to be a trick to it. All right. If they wanted us to have piles and piles of writing and calculating, it would be out of 5 or 6. there has to be some kind of trick to a question like this. Okay, but again, it's nice for you to do these questions. It's good for you to think in this way and to see what's possible and all the sorts of different things that they can do with sigma notation. Okay, any questions before we just chat briefly about number 9? I think what I'm going to do, because we are starting to run out of time now, is leave number 9 potentially as something that you can do for homework, and I'll give you the answer to it the next time. Any questions about 3.1? Are we all good? Thumbs up, thumbs down, we all good? Yes. I presume if you were going to ask me anything, you would have put your hand up by now. All fine. Okay, all right.
Can I run the poll?
Okay, that's fine. Go for
Okay.
it. Run the poll. Just everybody answer the poll questions, please.
Please don't leave without answering.
Yeah, shame poor Yolanda's got a job on her hands every week just to try and get everybody to do the poll. Please,
Guys,
please, please, guys.
just do the poll
Let's
before
do
you
the poll.
that you can do. Hmm. You guys did really well, by the way. I think they
They
really did
did,
well.
didn't they?
Hmm. And in the exam, this section, how many marks does it count? Just out of curiosity.
Sequences and series, it's about 30 marks.
There's-
If you take into account quadratic number patterns, from grade 11, together with the new stuff, it's anywhere sort of between 25 and 30.
Okay, so it is quite a lot.
It's quite a lot, yeah. So this section it'll come after the solving for x. So your solving for x and nature of roots or exponents or whatever it is, that will also be about 25 marks. And then it'll go straight into quadratic number patterns generally most of the time, and then questions on arithmetic. And there will always be a question on sigma notation. Always, 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 always. So
But do they give
yeah.
like a maximum of 3 for sigma notation? 3 marks?
No. It just depends on what they feel like doing. So there's no maximum. But I mean, because it is something that's a little bit more difficult, you're not going to find every question will be sigma notation. There will be a mixture of easy and then slightly more difficult things. But sigma notation is generally regarded as something that's a bit more challenging.
I see. Okay.
Yeah. So that's how it's set up.
Thank you, my people. I have now collected my screenshot. It is official. I'm done. I'm done.
Okay, thank you everybody for doing the poll. That is very, very much appreciated. Let's just have a quick look at question number 9. I'm going to leave this with you for homework. Okay, so when they talk about the greatest number of terms, all right, so what do the words greatest number of terms make you start thinking about? What is the word's greatest number? Means we have to be working with an?
You can do this, guys. Last question of the day. Let's go.
We're not actually going to do this question together. I'm just giving you some hints for the answer. Okay, there we go, Naledi. So we have to be working with an inequality. Good, well done. So the greatest number of terms. So in other words, they're asking you to solve for n, for which the series will have a value less than 65. What does the 65 represent? What is the 65 in this case? What does that represent? There we go. Absolutely. It represents your SN. Okay, so your SN is 65. So instead of you saying SN equals N over 2a plus n minus 1d, instead of this equal sign over here, we've now got an inequality. It has to have a value less than 65. Okay, so if I put the 65 over there, it has to be less than 65. So I'm giving you a hint as to how you would work this out. All right, so if you are solving for n, the greatest number of terms, so you are solving for n, that means you need to know what the a and the d are. Okay, and that's all I'm going to say. I leave it with you. And we'll see the answer to that next time. Okay, if you're so inclined to give it a bash. All right, so that's your week here, holiday homework. But yeah, give it a try. If you don't want to, that's fine. I'll go through it with you next time. If you're super keen and you love doing maths, then you've got something to work on as well. Okay.